Hi families, I have shown you how to do a one-digit by multi-digit multiplication area model. Well, today I'm going to show you how to do a multi-digit by a multi-digit area model for multiplication. Again, this is really going to prepare students for fifth grade for the algorithm where we multiply each of our place values by every single place value. So when we are multiplying, our problem here is 49 times 57. We're going to break down our problem into place values. So we're going to go ahead and put a plus sign in a box. So the kids will make a box and put a plus sign. And then we're going to break our numbers into place values. So we have 50 and 7, so 57, and then we have 40 and 9 for the 49. Okay, and then let's go ahead and get started and let me show you the math to it. So students are going to do 40 times 50 in this first box, so 40 times 50 right here. Okay. And again, 40 times 50 is really hard to do. So I have taught students and they all know how to multiply by tens. So multiply using their place value. So 4 times 5 is 20. So you're going to bring down 20 here. And then there are 2 placeholders here that we're going to bring back. So 2 of those zeros, 2 of those placeholders. And so our partial product is 2,000, and we're going to circle it because it's not complete whole, okay? And then our next equation is going to be 40 times 7. So you just come on over here. So 40 times 7 equals, and again, 40 times 7 is really hard, so I've taught students how to multiply using placeholders or multiply by tens, okay? And so they're going to do 4 times 7, which equals 28. And then we have 1 placeholder here, so we're going to bring it back down here, okay? And then we're going to circle our partial product or subproduct. Now we're going to go down to the next row and we're going to do 9 times each of these. So the first equation is going to be 9 times 50. Okay, and so then again, 9 times 50 would be really hard. So students are going to do 9 times 5 instead, which equals 45. And then we have 1 placeholder right here that we're going to bring back. And then we're going to circle our partial product or subproduct. And then finally in this box, we're going to do 9 times 7. And 9 times 7 is 63. And there are no placeholders, so our answer, our partial product, is 63. Now, we're not quite done. So I have taught students that we have all of these pieces to our Humpty Dumpty and they're in parts. And so what we want to do is put Humpty Dumpty back together again by using addition. Now today I did teach students it's really hard to, when we have so many numbers, to add 4 and stack them nicely. So what I'm going to do is I'm going to add these 2 numbers together. Then I'm going to add these 2 numbers together, and then I'm going to take those partial products and add them together. So let me go ahead and show you. You're going to do 2,000 plus 450 first. So we're going to do 2,000 plus 450. Okay, and then we're also then going to do 280 plus 63. So over here, 280 plus 63. And we're going to go ahead and get partial products for these as well. Okay, so 0 plus 0 equals 0. And students are using the algorithm for addition. In third grade, they were taught how to use the algorithm for addition and subtraction. 0 plus 5 is 5. 0 plus 4 is 4. And 2 plus 0 is 2. And so our partial product for that's 2,450. And now we're going to go over to this one. 0 plus 3 is 3. And then 8 plus 6 is 14. And I'm going to regroup my 1, okay, because I made a 10. And now I regroup that 10 with my hundreds. So now 2 plus 1 is 3. Now we have these two pieces, these two Humpty Dumpty, so these partial products that now need to be put together. And so now our final equation that we're going to use is 2,450 plus 343. And again, students already know how to do the algorithm for addition and subtraction. So they're going to start with their 1, 0 plus 3 equals 3. They're going to move over to their 10s, 5 plus 4 equals 9. They're going to move over to their hundreds, 4 plus 3 equals 7. And then over to the thousands, 2 plus nothing equals 2. And so our final product equals 2,793. And again, one of the reasons we're doing this is just helping students organize their thoughts before they move to the algorithm in fifth grade for multiplication. This is just showing students that they have to multiply by each of the place values. And then of course, when we go into the algorithm, we end up putting those partial products together in the algorithm in 5th grade too. So here is an example of what we're working on in class. Thank you so much.